Our galaxy, the Milky Way, contains several spiral arms. In one of them, the Orion Arm, lies a small but remarkable region of space, the solar system. It is our great home, a place unlike any other. It is special not only because it holds Earth, the planet we live on and from which we are watching this video, but also because of our planetary neighbors. Even though most of them are not suitable for human life, they help us understand our own world and the distant universe beyond. Together, they create the conditions that make our existence possible. Each of them is beautiful in its own way. Each has extreme weather, unusual landscapes, and unique features that continue to surprise scientists. For centuries, we have studied the planets of our solar system. It might seem that we already know them well, that there's nothing left to discover. But that's not quite true. Every planet hides something unexpected, something that can still amaze or even shock us. So let's begin. We'll start with something simple: Mercury. At first glance, it seems obvious that Mercury, being closest to the Sun, must be the hottest world in the solar system. But things are not so straightforward. Mercury is the smallest planet and it has almost no atmosphere. Its surface is loose and dry, unable to retain heat. Add to that its slow rotation, and the result is dramatic temperature swings. At night, the temperature drops to -190 degrees Celsius, while during the day, it can rise to over 430, and that's only when the planet is near its closest point to the Sun. Even then, average daytime temperatures rarely exceed 350 degrees. Surprisingly, Mercury also has a tail, like a comet. It's a long stream of sodium atoms that the solar wind blows away from the planet's surface. Unfortunately, it's invisible to the naked eye. To see it, astronomers need a telescope with a special filter and a long exposure photograph. We'll come back to Mercury later. For now, let's move on to Venus. Venus has a very different story. Here, the atmosphere is thick, so thick that it creates an intense greenhouse effect. As a result, surface temperatures remain constant and extremely high, around 480 degrees Celsius. That makes Venus the hottest planet in our solar system. The heat on Venus is so intense that lead would melt easily. Many spacecraft have tried to land on its surface, but none have survived for more than a few hours. The landers quickly overheated and stopped transmitting data. Despite being one of the most hostile environments known, Venus remains fascinating. In many ways, it is strikingly similar to Earth, yet far more extreme. It's also the brightest planet in the solar system, while Mercury, by contrast, is the darkest. Here we can see the 4 terrestrial planets of the solar system: Mercury, Venus, Earth, and Mars. Each has an iron-rich core surrounded by a rocky mantle. The size of these cores depends on how far each planet is from the Sun. That's why Mercury's core is the largest in proportion to its size, while Mars has the smallest one. Mercury's metallic core makes up about 3/4 of its total mass. The remaining outer layer is a silicate shell made of rock and minerals. All rocky planets, including Earth, are formed mainly from just 4 elements: iron, oxygen, magnesium, and silicon. It is believed that Mercury formed close to a region where the Sun's magnetic field was at its strongest, which may explain why its core contains so much iron. Among all the planets in the solar system, the clear leader in liquid water is, of course, Earth. But we shouldn't forget about the moons of other planets. Some of them hold even more water than our own world. Take Jupiter, for example, the largest planet in the solar system, surrounded by an impressive family of moons. Among them are Ganymede, Callisto, and Europa. Each of these moons contains more water than Earth. In fact, Ganymede alone may be made up of 46% water by volume. Beneath its icy crust lies a massive ocean, a salty liquid layer that stretches about 160 kilometers deep. That's roughly 35 zettiliters of water. For comparison, all of Earth's oceans together hold about 1.26 zettiliters. This means Ganymede contains more water than all the known rocky planets combined. Following it in this ranking are Titan, Saturn's largest moon, then Callisto and Europa, both orbiting Jupiter. Earth takes only 5th place, ahead of Pluto, Dione, Triton, and Enceladus, which come next in the solar system's top list of water-rich worlds. Beyond Neptune, our most distant planet, lies a region known as the Kuiper Belt, a vast zone filled with ancient remnants left over from the formation of the solar system. There, countless fragments of rock, ice, and dust drift through space, asteroids, comets, and frozen debris. Amid this cosmic field of leftovers, we find several fascinating dwarf planets: Pluto, Makemake, Haumea, and Eris. Astronomers believe that long ago there were many more such miniature worlds, but over time, most of them were captured by the gravity of larger planets. A striking example is Triton, now Neptune's largest moon, but once a free dwarf planet that originated in the Kuiper Belt. Eventually, Neptune's gravity pulled it into orbit. Triton is a remarkable world, even more massive than Pluto or Eris. Images captured by Voyager 2 in 1989 revealed its southern polar region, covered with dark streaks. Scientists believe these markings are cryovolcanoes, eruptions of ice and gas instead of molten rock. Saturn, the 6th planet from the Sun, is one of the most remarkable worlds in our solar system. Its average density is only 0.687 grams per cubic centimeter, meaning it's lighter than water. If there were an ocean large enough to contain it, Saturn would literally float. This is because the planet is composed mostly of hydrogen and helium, the two lightest gases in the universe. So while all the other planets would sink, Saturn would gently drift on the cosmic sea. Farther out lies Neptune, a world of deep blue storms and unimaginable winds. Images captured by the Hubble Space Telescope in 2017 show changing cloud bands and shifting colors in Neptune's upper atmosphere. These rapid changes reveal winds that are the strongest in the entire solar system. Here on Earth, we measure wind strength using the Beaufort scale, a range from calm breezes to devastating hurricanes. The highest category begins at around 33 meters per second, roughly 120 kilometers per hour, and is powerful enough to cause massive destruction. But on Neptune, winds can reach 492 meters per second, nearly 1,800 kilometers per hour. Such a gust would tear through anything, even strip the surface down to the rock below. To put it in perspective, the strongest persistent winds on Earth occur in Antarctica, where they can reach up to 89 meters per second. On Neptune, that would barely count as a breeze. Mars, too, is a world of winds. Across its dusty surface, storms can sweep across the planet, carrying sand and dust at speeds over 100 kilometers per hour. Some of these dust storms last for weeks and can blanket entire regions in red haze. When powerful impacts occur on Mars, rocks are sometimes ejected into space, and a few eventually land on Earth as meteorites. About 3% of all meteorites found here are of Martian origin. We know this because their chemical composition matches the rocks analyzed by Mars rovers. In 1977, NASA launched two legendary spacecraft, Voyager 1 and Voyager 2. They began a grand journey through the solar system, past Jupiter, Saturn, Uranus, and Neptune. Voyager 1 is now the most distant human-made object ever created, traveling through interstellar space beyond the influence of the Sun. Voyager 2 followed years later, also crossing the boundary known as the heliopause, the edge where the solar wind gives way to the interstellar medium. Together, these two silent explorers carry golden records, messages from humanity to anyone who might one day find them. Other spacecraft, like Pioneer 10 and 11, also left the solar system long ago, along with the Ulysses probe, which once studied the Sun and Jupiter. Though Ulysses has long since gone silent, it continues its endless journey through the dark. Today, 6 spacecraft are known to be on trajectories that will eventually take them beyond our solar system, each one a fragment of human curiosity sailing into eternity. And so, as we look back across our solar system, from the burning sun to the icy edge of Neptune, we begin to understand that every planet, every moon, and every grain of cosmic dust is part of one grand story, the story of our existence. Among the planets, Uranus stands out as a quiet enigma. Its axis is tilted by nearly 98 degrees, causing it to roll around the sun like a ball on its side. This unusual orientation creates the most extreme seasons in the solar system. Each pole experiences about 21 years of continuous sunlight, followed by 21 years of darkness. In those frozen winters, temperatures can drop as low as -224 degrees Celsius, the coldest ever recorded on any planet. There are still countless mysteries hidden within our solar system. New worlds, new moons, and new phenomena continue to surprise us. Every discovery reminds us how little we truly know and how much more there is to explore. Because in the vastness of space, we are not just observers, we are participants. Tiny sparks of consciousness seeking to understand the universe that gave us life. And that, perhaps, is the most extraordinary journey of all.